morning, everyone. This is teacher Eda Montano once again, and today we will be learning another topic, which is the product with monomials. Please watch and listen to the short video tutorial, and don't forget to answer the given activity, okay? Now let's start. Okay, for our learning objectives at the end of the lesson, you are all expected to first recall the product rule of exponents and finally to multiply polynomials by monomials. Okay, let's start. Now, how do we multiply polynomials? Let's find out. The first thing we need to do is to recall the product rule of exponents. Are you familiar with that? Okay, now this is the product rule of exponent. So please take a look in our general formula. Let's have a to the power of m to be multiplied to a to the power of n. That is equal to a raised to the power of m plus n. What does it mean? Meaning to say, when multiplying two powers with the same base, which is a here, you just simply add the exponents, okay? Copy the base, add the exponents. Now let's find out through demonstrating examples, okay? For our first example, let's have x squared times x to the power of 4. Now here class, I can only see variable x. Since we have the same base here, copy the base which is x again and add their exponents. 2 and 4, add the exponents and then copy the base once again with the resulting number of exponents. So here the final answer is x to the power of 6. Simple as this one. Now let's take a look to our second example just to compare it with the first example. Now here in the second example class, we have two variables. I can see variables A and B here. Teacher, why is it 2? Now, how do we solve this kind of problem? Let's attack them one by one, okay? I want you all to focus on the variable A first. Okay. Focus on the variable A and then add the exponents. That's 3 and 4. Okay. After that one, focus on the second variable, which is B, and add their exponents. 1 and 5. So you just have to simplify it. Okay. The final answer would be a to the power of 7, add 3 and 4, and add 1 and 5, b to the power of 6. And that is how you do it. Okay, let's have the third example. What if you are going to multiply two different variables? Teacher, how do I answer this? The answer would be just simple as a cube b to the power of 5. You just have to write them as it is, okay? Write it as it is. Since you cannot combine their exponents because the base are different, okay? For our fourth example, we have 4m cubed times 3m to the power of 5. Now this time around, since we have numbers and variable together, now let's multiply them differently. Of course, when we multiply 4 times 3, that would give us 12. And if we multiply m cubed and m to the power of 5, we just have to take the base, which is m, and then simply add their exponents. So our final answer would be 12m to the power of 8. Okay? That's great. Now let's have our fifth example. So this time around, we have 2x squared y cubed
times 5x to the power of 5 y squared. So everybody, let's do this. 2 times 5, that would give us 10. Okay? So how about if we multiply x squared and x to the power of 5? Take note of the answer. That would give us x to the power of 7. Okay? And if we multiply y cubed and y squared, that is y to the power of 5. So basically, the final answer would just be 10x to the power of 7, y to the power of 5. Okay? Very simple. Let's have example number 6. Now in this example, we are about to multiply a monomial to a binomial. Okay? Now how do we multiply a monomial and a polynomial? In this case, we have to remember the distributive property. Okay? Again, let's remember the distributive property. The first thing I need to do is to multiply 2 to the first term, and then I will multiply it once more to the last term. Okay? 2 times 7x, that would give us 14x. How about on the last term? 2 times 3, the final answer would just be 6. So if you multiply 2 and 7x plus 3, the resulting expression would be 14x plus 6. Okay? This is our final answer. Now let's have two more examples. Okay. In this example, we have 4x and another binomial, 3x squared plus 1. Okay, let's multiply 4x to our first term, which is 3x squared. 4 times 3, that will be 12. Remember that. And x times x squared, of course, that is x cubed. So, in our first term, the resulting expression is 12x cubed. Okay, now how about this one? 4x times 1, of course, that is still 4x. Now, remember this one, class. Anything that is multiplied to 1 is the number itself. So if it's 4x multiplied to 1, that's basically 4x, okay? So let's have our last example. How about this one? We have 5y squared times 2y to the power of 5 plus 3y cubed. Okay, let's have first 5y squared times 2y to the power of 5. 5 times 2, everybody, that is 10. Okay, y squared times y to the power of 5, y to the power of 7. So, our answer is 10y to the power of 7 in the first term. Now, finally, let's distribute 5y squared to 3y cubed. 5 times 3, that is basically 15. And y squared times y cubed, that is y to the power of 5. So, the final answer would just be 10y to the power of 7 plus 15y to the power of 5. Okay, we are about to end our discussion, but before that, I will be introducing to you another laws of exponents. So this time, this is the power of a power rule. So what is this power of a power rule all about? Now, when you raise a power to a power, you just simply multiply their exponents, okay? So if we have this general expression, a to the power of m raised to the power of n, that is equal to a raised to the power of mn. So basically, when you raise a power to another power, you copy the base here, which is a, and then multiply the two exponents, m times n. So let's learn more about this one by having these two examples, okay? So the first example would be x squared raised to the power of 4. So in this example, let's copy the base, which is x, and then you multiply the exponents. That is x raised to the power of 8. Okay. Now I would just like to clarify, do not be confused with the product rule of exponent earlier. Now there, when you multiply power with the same base, you add the exponent. But here, when you raise a power to another power, you have to multiply their exponents, okay? Now, for the second example, this is y cubed raised to the power of 4. Copy the base, which is y, and then multiply the exponents. 3 times 4, that would give us y to the power of 12. Okay. Now this time, let's go to our last rules of exponent. We have the power of a product rule. When you have a power outside of the parenthesis, everything in the parenthesis is raised to that power. So if you have AB raised to the power of n, all you need to do is to distribute the power to every element here inside the parenthesis, okay? So that would be A raised to the power of n and B raised to the power of n. All you have to do is to distribute the power in every element here inside the parenthesis. Okay? Got that one? Okay. Let's have the examples. I have here 5y cubed raised to the power of 2. Class, remember, I am raising a number to 2. And I am also raising variables to 2. So here, do not be confused. This is 5 square. So that would be 5 times 5, which is 25. How about this one? This is y cubed raised to the power of 2. Copy y and then multiply the two exponents. The final answer would be 25y raised to the power of 6. Okay, now this is a common mistake because when you will solve it fast, you will just multiply 5 and 2 right away, and that is 10. Do not do that, okay? You raise 5 to 2, 5 times 5, that is 25. I hope you will not commit that kind of mistake. Okay, how about this one? 2a squared cube. Okay, let's have 2 cube. What is the equivalent value of 2 cube? We have 2 times 2 times 2. The final answer is 8. And then you have a squared cube. That would give us a to the power of 6. So the final answer is 8a to the power of 6. Okay. Now I hope you can differentiate. Now the two laws of exponents are just additional. So I want you to focus on the rule that is presented earlier, okay? And that's the end of our lesson. Thank you everyone, and I hope you learned something today. Please don't forget to answer the given exercise. See you soon. Goodbye.